Welcome back to Physics with Miyoshi. Today we're going to talk about a little bit more about thermodynamics, mainly about thermal processes and how those affect work and the first law. So let's get down to it. The first type of thermal process, well, we have four types of thermal processes. Isobaric, which means one pressure. Isochoric, which is one volume. Isothermal, one temperature. This is for an ideal gas. And adiabatic, which is constant heat, or one heat if you will, and this one is for a monatomic ideal gas. So what do these different processes do with the work? How do they affect the first law? Well, the work is my pressure times my change in volume. For an isobaric, one pressure, the pressure is constant. The work is pressure times my change in volume, which is P times V final minus V initial. And if we think about all these guys, no matter which one we have, if we look at a pressure times pressure volume graph, we always will have the work will always be the area under the curve. So if we have a isobaric or one pressure, we can see that if I have a process that goes from there to there, constant pressure, when my volume changes, my work would then be this guy in here, the area under the curve. And that's going to be true for all these guys. The first law says that my internal energy, changing my internal energy, is my heat minus my work. Well, the work in this case, we just found out, is P times delta V, so it's Q minus pressure times my change in my volume. For an isochoric, or for a one volume type process, we have our work is delta P times V. That is going to be 0. We can see over here on my on our P delta V graph, if I change only my volume, or only my pressure, not my volume, then that would be a process that goes something like this, whether it's up or down. And you can see that since this is an instantaneous, or it's one volume, that there is no area under that curve. So since there's no area under the curve, there can't be any work. So how that affects my first law is that my change in my internal energy is still my heat minus my work, but since my work is 0, then it has to be just the internal energy is only changed by my heat change, or by the heat that's added or subtracted. So that is a one volume or isochoric type process. Isothermal, or one temperature, for ideal gases, the work is N times R, which is my ideal gas constant, times the temperature, T in Kelvin, times the natural log of the volume final divided by my initial volume. So again, that's an interesting equation, and what that looks like over here on my graph, if I have an isotherm, so this is one isotherm. The process might go down, or it can go either way, change my volume positive or negative, but the stereus under the curve is still my work done. Okay? And the change in my internal energy in this case is now going to be 0. So if 0 is my heat minus my work, then my heat and my work must be equal. So when I change my heat, that's work done, either to the system or away from the system, depending on what the signs there are. Okay, and last but not least, we have the adiabatic process, constant heat, or one heat. Then again, this is for a monatomic ideal gas, and we see that the work is 3/2 N times R times the change in my temperature, the temperature final minus the temperature initial. What that looks like on this graph over here is maybe we have a couple different isotherms over here. So here's another isotherm. We have a initial and final. One's on one isotherm and another's on the other isotherm. And so I would make something like that. And now this time my work will be just everything under that curve there. So that's the work again. Again, all these processes, no matter which one they are, the work can always be found by the pressure versus volume graph and finding the area under the curve, whichever curve that happens to be. What about the first law? Well, the first law, the change in my internal energy, now it's all provided by my work. So now, because the heat is 0, then all the change in internal energy must be my work, which again is 3/2 nR times the change in my temperature. So, 4 different processes, thermal processes for changing energy in thermodynamics, getting work out and understanding the first law, how we change our internal energy, how the heat and work together to do all that kind of good stuff, and just understand these 4 different processes. The work, again, one of the most important concepts here is that no matter what kind of process we have, the pressure versus volume graph, that area under that graph will always give us the work done. So, a little bit more about thermodynamics and work and energy and processes, thermal processes. Hopefully you've enjoyed it, and hopefully come back for more Physics with Miyoshi. Thanks for tuning in.